Hi, in this video, we are discussing the 17th numerical from the exercise for the chapter Laws of Motion, which is also the fourth chapter for the 11th standard physics. Now, let me tell you, this particular question is a fun one because we'll be dealing with some concepts of center of masses. सबसे पहले हमें question में दिया गया है, we have a uniform solid sphere of radius r. So let us get a uniform sphere of radius r in our picture. सबसे पहले let us focus on this diagram. So we have a sphere with a radius r. And now the situation is, as per the question, हम इस sphere में we are carving out a spherical hole. And we are carving out a spherical hole whose radius is given to us as r by 2, which is the half of the complete sphere का radius. And this hole is carved out in a manner such that इसका एक edge passes through the center of the sphere and the other through the boundary of the sphere. Now, the second image actually captures this particular scenario quite nicely, where we have this green region that represents the spherical hole that's been carved out of our sphere. And this purple region shows the remaining sphere that's left after carving out that spherical hole. So remaining sphere is represented by purple sphere. So this was in terms of how the spheres might look like and the holes might look like. Let's say what happens to the center of masses. So initially जब sphere complete है and since it's a uniform sphere, उसका center of mass is at its geometric center C. Let us call it C. अब जब इस sphere में से एक spherical hole minus हो गया है, तब इसका center of mass would no longer be at its geometric center. In fact, it would shift by some distance, and let us say that center of mass or represent that center of mass as C1. Similarly, why not calculate the center of mass for the hole as well? So if I have to calculate, since this hole is a sphere at the end, ठीक है, सो इसका सेंटर ऑफ मास इस चंक, सो बेसिकली होल कार्व आउट करके जो चंक बनेगा स्फीयर का, उस चंक का सेंटर ऑफ मास वुड बी एट इट्स ज्योमेट्रिक सेंटर एंड लेट अस रिप्रेजेंट दैट चंक एज c/2. एंड बेस्ड ऑन दिस व्हाट वी हैव टू डू इज कि हमें कैलकुलेट करना है सेंटर ऑफ मास फॉर दिस रिमेनिंग स्फीयर. सो रिमेनिंग स्फीयर वाज दिस पर्पल रीजन, इसका सेंटर ऑफ मास बेसिकली c1 हमें ढूंढना है. नाउ हाउ डू वी प्रोसीड फॉर इट? Well, one way I like to do in such question types is to imagine the question in the reverse way. So अब कैसे question presented है, पहले complete sphere था, फिर hole carve out किया, फिर दो shapes बने, एक remaining sphere और एक spherical hole. हम बोल रहे कि let's reverse this, कि पहले ही एक remaining sphere था और एक spherical hole था and वो दोनों अब जुड़कर एक complete sphere बना रहे हैं. सो इस केस में क्या हो रहा है कि वी हैड अ शेप ऑफ रिमेनिंग स्फीयर विद सेंटर ऑफ मास c1, वी हैड अ स्फेरिकल होल विद सेंटर ऑफ मास c2, दोनों को ऐड किया एंड देन वी गॉट अ सिस्टम विद सेंटर ऑफ मास c. इफ वी इमेजिन क्वेश्चन लाइक दिस, देन इसका सिस्टम का सेंटर ऑफ मास कैलकुलेट करना ईजी है बिकॉज उसके फॉर्मूलाज हमने टेक्स्ट बुक में देखे हुए हैं. सो दिस इज गोइंग to be our approach for solving this particular question, and now that we have figured that out, let's get on to solving the question actually. So let's define certain quantities which we require to calculate center of mass, or which we require to solve the center of mass question. सबसे पहले mass of the spheres. So we are saying कि let capital M represent the mass of the complete sphere whose radius is r. ठीक है. And the second thing what we are defining is कि let M1 be the mass of the spherical hole that's been carved out whose radius is r by 2. Now, if we were, since these spheres are uniform, I can say that masses are directly proportional to their volume, which in further is directly proportional to the cube of their radiuses. So if I were to calculate the ratio of mass is to m1, or let's do it reverse, if I were to calculate the ratio of m1 is to m, it would be radius of m1, that is r by 2 ka cube, divided by radius of capital M, that is big sphere ka cube. And if you were to solve this equation, we will get the ratio of m1 is to m as 1 is to 8, or m1 is in terms of the mass of the complete sphere is m by 8. So basically हम जो spherical hole निकाल रहे हैं, this is 1 by 8 times the original mass. So if we know the mass of the complete sphere, that is this, if we know the mass of the spherical hole, so calculating the mass of the remaining sphere then becomes quite easy. All we have to do is subtract the mass of the hole from the original and we get the mass of the remaining sphere as 7 by 8 in terms of m. Okay, 7 by 8 times capital M, which is the mass of the complete sphere. Now, what is the data is remaining? Well, we will define let C be the center of mass for the complete sphere. So that is the original sphere. And based on this, what we are saying is ki taking C as the origin, will calculate or will determine the remaining two center of mass for the remaining two objects. So we are saying that C1, let that be the center of mass for the remaining sphere, and let it be at a distance x from the original position C. So C1 is at a distance x from our C. So that's what we are defining at this point. Second point that we are defining, that is second center of mass. Also, we are defining that let C2 be the center of mass of the spherical hole. Okay, so if we were to calculate the distance or location of C2 from C, we would say it would come out to be the radius of this spherical hole, which is r by 2. So we can say that C2 is at a distance r by 2 from C, as C1 was at a distance x from C. And this is what we need to calculate because हमें center of mass का position ही ढूंढना है. So let's get started. So as per the definition, since we have defined that if we were to combine spherical hole and remaining sphere, we were to get the original and the complete sphere. So based on this, if we were to define the center of mass, so center of mass for a system is to add the moments of masses for all the participant objects and divide by the total mass of the system. So this is the moment of mass for the remaining sphere, Rs, and this is the moment of mass for the spherical hole, Sh, and this is the mass of the complete system. And things get pretty easy because सबसे पहले what we need to do is कि since we have made all the measurements considering C as the origin, so C, that is the location of center of mass of original sphere from C, it should be 0. So if we were to substitute all these known values that's been known to us, so we get C as 0. Then we substitute, this is the mass of the remaining sphere. So this is M1, this is the mass of the spherical hole. This is the distance of the spherical hole, distance of center of mass of the spherical hole from C. C1 is what we are supposed to calculate, that is the center of mass of our remaining sphere. And then we have the addition of both the masses. And if we were to rearrange these terms, so if this particular terms goes over here, it gets multiplied by 0, so the result is 0. So we have 0 is equal to the following terms in terms of C1 and the radius of the original sphere. And if we were to simplify this term, we would get our center of mass for remaining sphere in terms of r, that is minus r by 14. The negative sign over here decides that our center of mass, that is the resultant center of mass, is to the left of the original center of mass. So what does this mean? So this means that if we carve out a spherical hole, our center of mass would shift in left side at a distance r by 14. So that's what we found out, and that's what we wanted to find out. That is the shift in the center of mass. And with this, we can make the final statement that the center of mass of the remaining sphere is at a distance of minus r by 2 from C. Actually, that would be a better deal over here. So that's it. This was the question. The PDF of the solution is given in the description, so make sure you check that out as well. With this, I hope this helped you. Thank you.